All right. Wow, it's day 59 already. So apparently, I have about a month more to go. Um. Anyways, welcome back. Um. It's nice to have you back in the stream, and let's solve some late code questions today. So, first of all, I was going through the binary search questions, and I saw these two questions here that are quite similar to each other. And there was another question that I saw in the similarity list here. So I'm going to solve probably three questions today. Okay. So let's see what these questions are. First of all, I would like to go over a question that is common to the three other questions, which is the intersection of two arrays. Now, this question uses binary search and every other method you can use to solve this question, so it is quite versatile. So I'd solved it before, but I'll go over my solutions and explain how I came up with the solution before we move on to the new questions that I set for today. So, the question is intersection of two arrays, and it's LEETCODE 349. So, given two integer arrays, nums1 and nums2, return their intersection. Now, the intersection of two arrays is defined as the set of elements that are present in both arrays. Now, each element in the result must be unique, and you may return the result in any order. So here's a solution, an example, and the output is 2 because 2 is common to both arrays, right? So the intersection of this nums1 and nums2 is 2. All right, and in this case we have 4, 9, 5, and the intersection with this array and this other one is 9 and 4, because 4 and 9 is here, and then we also have 4 and 9 here. Now the order doesn't really matter. We saw it could be 9 and 4 and 4 and 9, but the point is each item has to appear once in both arrays, right? And for us to form that intersection, and the intersection is simply a list of those items that are in both arrays. So how was the approach to solving this question? Now you can see the constraints are not really um, you know difficult or complicated. We're simply just trying to return the intersection of two arrays. So we can do this in several ways. The first method to solving this question is by using the built-in intersection function, right? But that's I'm not sure if that will be allowed. Maybe when you are providing a solution to somebody in an interview or something, but I'm not really sure. But you can see I solved it with that method, and the solution was quite good in terms of runtime. Which one was it? Yeah, so you can use two sets, right? A set will simply return every unique item in the array, right? So once you get the unique items in both arrays, right, you can get their intersection by just using the intersection function or intersection built-in method for set in Python, and then return a list of that result, because this will be returned as a set, right? So this list will transform into an array. Another approach is to use a binary search. Now we know binary search work on sorted arrays, right? So if we want to use a binary search, right? Let me quickly go on my board here and delete everything here to make the explanation easier. So I'll take everything here and delete. So let's say we try to get the intersection of this array and this one here. So I'll take this example, right? And let me quickly enlarge this so we can have a full view. All right, so here's our array, and like I said, we would want to use a binary search to search for the intersection. Now the intersection is again every unique item, right, in each array. So, and it must not appear twice because it's an intersection, right? So for us to use a binary search on this question, right, we'll need a sorted array. Now a sorted array, how do we get a sorted array? Now we can sort either of the arrays, but I'll just take the first one, right? So if we sort nums1, then we'll be able to get I'll say nums1 dot sort. If we sort this array, we'll get 1 1 2 and then 2, like this, right? This is the sorted form of this nums1 array. Now we'll need to iterate this sorted array to get every item that is in num2, right? So that we can see the intersection. Sorry. Yo. Sorry about that. I had a quick. So let me set my phone on airplane mode so that I don't get any calls today. I'm not expecting any emergencies, so I'm good for now. Alright, so when we sort the nums2 array, then we'll perform a binary search on this array. Now how do we get the intersection? Well, the intersection will simply not come from just checking if every item in nums2 is in the sorted form of nums1, right? We will need to add the result to a set. Now a set will keep every unique item for us, right? So we'll run a binary search. Now how do we run a binary search on this nums1 here, right? Because it's sorted, right? So a binary search will go this way. We'll need a left and right pointer, right? The left will start at the beginning and then the right will be at this position. Sorry, the right will be at this position. So we'll have left here and then right. Now we'll need to find the midpoint. The midpoint is simply the left plus the right divided by 2, right? And this will simply be equal to 0 plus 3, right, divided by 2, rounded to the nearest 0 value. This would have been 1.5, but since we are rounding it up, it will be 1. So our midpoint will be here, right? These are our midpoints. Let me quickly erase everything here. So our midpoint will be at this position here. So this is the value we'll compare to any value in nums2 here, right? So since in nums2, the first value we are looking at is 2, right? 2 is superior to 1, which is the midpoint here. So in binary search principle, if we find a number in the array that is less than the target, then we need to shift our left pointer towards past the midpoint, right? So we'll shift our left pointer to this point here, and then we'll recalculate the mid value again. So let's shift our left pointer to this point, right? So in our second iteration, we'll do the same thing again, right? So we'll calculate the midpoint again. So it will be our left value will now be 2 plus 3 divided by divided by 2. This is 5 divided by 2. This will be 2.5, since we are finding to the nearest 0 value, right? We'll round it up. So this will be equal to 2, right? And the value at index 2 in this array is 2 here, right? So 2 is equal to this 2 here, right? 2 is equal to 2. So what we'll do is to add this 2 to a set, right? So the reason why we need to add 2 to a set is for us to keep every unique value, right? We'll need to keep track of every unique value. So we'll add this 2 to a set. I'll call this set unique, or let me call it unique set. So unique set. So if we found 2 here, right, in the sorted norms array, right, and 2, I mean, if we found 2 in this sorted norms array, then we'll have to add 2 to the unique set, right? So then we use a binary search to look for every item in norms 2. Every norms 2 item in norms 1, we use a binary search to search for the item, and then when we find that item, we add it to the unique set, right? So the unique set will simply contain 2, so we'll add 2 to the unique set, or I'll just say unique set, right, dot add, let's say add like this. So we'll add 2, right? Now when we iterate, our second target will be the second item in norms 2. So that is our second iteration, right? So in our second iteration, we'll perform the binary search again, and we know we'll end up finding the second item in this sorted norms 1 again, in this array here. So after finding that item, we also add it to the unique set. Now when we add an item to a set, right, whenever the set gets duplicate item, it gets rid of 1, and then we'll be left with just 2 in our unique set, right? So our unique set at the end of the day, so after iterating over 1 and then 2, right, we'll end up with just 2 in the unique set. And when we can then transform this to a list, right, and then return that list. So let me show you the solution here. So here's the solution. You can see my solution is here. Sorry, this is not my solution. Okay, so here's my solution. As you can see, we first of all sorted one of the arrays. You could sort num2 or num1. It doesn't really matter, as long as you perform the binary search. Now a binary search, like I said, is to find a target in a particular array, and that array has to be sorted. Now but this time around, we don't have just one target, we have multiple targets, and our targets are in norms2 here, right? So our first target will be this 2, our second target will be this 1 as well, right? So after getting all of these targets, we will then, so this is our target, this is the first target, this is the second target. So for each of these targets, we'll perform the binary search, and then when we find the item, we'll add it to the unique set. Now you can see I have a result set here, right, which is set to a set, a result variable which is equal to a set, and then what I did here is to I defined the binary search function as a helper function. Now I'm returning true or false if the item is in the second array. In other words, if the item in norms1, right, if the item in norms2 is in norms1. So if it's in nums1, then it will return true. If it's not, it will return false. Now this is the implementation of a binary search. It's quite straightforward. So you choose a left and right pointer, right? So the left pointer is at the beginning of the array. In other words, it's at index 0, and the last item, the right pointer points to the last item in the array. So you iterate while the left pointer and while the left is less or equal to the right pointer, right? In the first iteration, obviously they will be far apart, but as the iteration goes on, as the search continues, they'll get closer and closer, right? So the conditions are to search if the mid value or the value at the midpoint, and the midpoint is calculated by adding the left to the right divided by 2. Now you can see we are using a double division sign here. The double division sign is basically to round the value up, right? So this double division sign will round the value up, and then we'll get the value at that point. So mid value, right, will change in every iteration. So if the mid value is superior to the target, right, we'll then shift the right pointer towards the left, right? So move it past the midpoint towards the left. And if the mid value is less than the target, then we'll have to shift the left pointer towards the right, right, like I did here. And when we find a value, if the mid value is not superior to the target or less than the target, it's certainly equal to the target, right? So when it's equal to the target, we stop the iteration, we stop the search, and then we return true. Now this function will be helpful in this second iteration here, where we begin to search for the item in nums1 here. The items in nums2, we begin to search for the items in nums2 in nums1, right? So we do binary search. So each of the items in nums2 becomes a target, right? So if the binary search here returned true, then we add that item to our set, right? If it returned false, we don't do anything. We continue the iteration for every item in the array, and at the end of the day, we'll return the result set as a list, right? So this is how you solve this question. And there are two methods, obviously. One of the methods, so in this case, the second method, which is obviously requires less code, right, has creates more space in memory, right? So each set is a space in memory, and so on. So you can see in terms of memory, it didn't do well compared to this one, which had 16 MB, right? So we're creating less memory, and the only memory we created in space was this, right? So the result set here, so which was really not a big deal compared to the other one, where we're creating more space in memory for each of the arrays. So both questions work, but I will advise an understanding of the binary search method. So let's move on to the second question. The second question is similar to the first, to the one we just saw, right? Which is why I said it's a prerequisite for this question, but this one has a little bit to it. So let's see what we have here. So LEETCODE 350, intersection of two arrays 2. Given two integer arrays nums1 and nums2, return an array of their intersection. Now each element in the result must appear as many times as it shows in both arrays, right? And you may return the result in any order. So this question is similar to the other one, but the catch here is we are no longer returning the intersection per se. We are returning the intersection, but how many times they appear in both arrays. So let's take a look at this question here. Now, in the previous example, we returned, let me go back to the description. We returned just 2, right? Obviously, 2 is the intersection between these two arrays, right? But in this case here, we want to return as many times there is 2 in both arrays, right? So in this array, there is 2 and 2 here, and there is 2 and 2 here. So obviously the intersection will be 2, but how many times did 2 appear in both arrays, right? So 2 appeared twice in this array and also appeared twice in this array. So we return 2 and 2. And the same thing goes for this question. Now you can see we have 4 and 9, and then 9 again, 4 here. But in this case, we have just 4, 9, and 5, right? So 4 appeared twice in this array. So there is 4 here, and then there is another 4 here, right? That is 2, 4 in the in the second array, and then there's just 1 4 in this array. So we are returning how many times 4 appeared in both arrays equally, right? So since 4 appeared once in this array, we cannot say 4 appeared twice, because it's only one time it appeared in this first array and appeared twice here. So we forfeit the count for the first array where the minimum value is, right? So where the minimum count of the item is. And the second value here is 9. So 9 is also in this array, but it appeared twice. So we also return 9 just once. Now 5 is not in this array. 5 did not appear at the intersection of this array. Now, in this case, how do we get, how do we return the amount of time, right, or the minimum appearance of every item at the intersection between these two arrays? So I'll still use the same example, right? So in this case, instead of us to use a set and a binary search to do all of that, I mean, that would not work, obviously. At least I've tried, but the best approach for this is to count how many times each item appear in the array, right? So we'll use the first array. So we'll create a map, or a hash map, if you will. So we'll say nums1. So a map of nums1 would look like this. So we'll say 1 appeared how many times? So we have 1, 2. So 1 is 2, and then 2, 1. So 2 is 1, 2, right? So we have 2 here. So I'll say this is, sorry, 2 appeared twice. So I'll say nums1 is this, right? And we'll do the same thing for nums2. Now this is to help us keep track of how many times each item appear in the arrays. And this trick is very important to understand when whenever there is a question relating to count of items in a particular set or list. The first thing, I mean, the most common operation that will come as part of the solution would be to use a set, or a dictionary, to keep count of every item in the array. So we'll do this for nums2, right? And nums2 would look like this. So we have 2, and 2 appeared twice here. Now you can see by doing this, right, you begin to get an image. Now what is the image here? The image is such that the amount of time every item appeared in either of the array will simply be the minimum of their value here, right? of their value in the dictionary. Now, if an item is if an item appeared in both array, it will simply be a check for that item in this dictionary, right? So let's say after doing this, right, we can then iterate. So let's say for every for every item in this I'll call this sorry, let me just call this map. Okay, I'll say hash num1 and hash num2, right? So hash num1 and hash num2. Now, to know the intersection, right, between this item, between these two maps, right, or these two hash maps here, each item in every, see, an item of the first hash, right, or let's say an item of the second hash must be in the second hash, right? Then we'll know we have an intersection happening at that point, right? Now, how many times did that item appear? What is the common or the minimum time that item occurred in both arrays, right? For us to determine that, right, we'll simply find out the count, right? How many times it appeared. Now, in this case, they both appeared twice, right? So for us to return how many, the intersection, right, or the common item between these two, we'll simply need to iterate, right? So we'll say for every character in this nums1, right, if the character is also here, right, we can then calculate the minimum of their value. We can find the minimum, right? The minimum is simply how many times that item appeared. If 2 was here just once, right, it doesn't matter how many times 2 appeared in nums2, right, or in nums1 here, the minimum intersection will still be 2, and 2 will only appear once, right? We can't just return every amount of 2 that is in nums1. We'll simply return every amount of 2 that they both have in common. And in this case, where I just cancel these 2, it will be just once. But given the originality of the question, we only have 2 twice in both arrays, so which is good. So we can then say, okay, so for every item in nums2, right, or for every number in nums2 in the hash of nums1, sorry, we can then find out if that item is first of all in in hash of nums2, and then if that item is there, we'll find the minimum of their the minimum time that item occurred in both arrays. So we'll just saying, we can do that by simply saying hash of num1, right? So to get the value, we'll say it will be a character, right? It will be a num, right? So this will be part of a loop, right? And then we'll say if so, by doing this, we'll get the value, right? And then we'll use a built-in method to calculate, to find the minimum, right? So the minimum will be this, and we'll just pass in the hash of nums2 again. So hash of nums2 like this, right? And we'll see passing the num, right? And this will return the minimum for us. Now, how do we return how many times? How do we return an array like this at the end of the day? So we want to return 2 and 2, right? So it's simply going to be the count, right? So the count here will be the minimum count. So let's call this the minimum count will be returned at this point. So we can then multiply that, we can then add that amount of minimum count to an array. So since we are going to return an array, we'll create an array somewhere here. I'll call this result again. So the result will be an empty array at first, and we'll begin to add each of these items to it. So we'll say the results, Now we can't do result.append, because if we do result.append, I mean, for us to add an item a certain amount of time to an array, we will need to multiply that item inside of an array, right? So we'll say, so it will be num like this times the minimum count. So the minimum count, and then we'll add this to the result array, and that's all we need to do, and we return the result array at the end of the day. So I'll code this out for us to understand more in depth. So the question is LEETCODE 350 intersection of two array 2, and this is going to be under arrays to pointer binary search, but I'm not using binary search obviously to solve this question, so I'll just put it inside arrays, right? And yeah, so let's see. So I was doing some checks here earlier, so while I was solving this question. So yeah, let's go. Let's see, LEETCODE 350 intersection of arrays 2. So let me see, lit dash 350 dash intersection dash of array 2 Okay, so as usual, I'll simply copy this from here and then add it here. Okay, so I'll just import this class. Yeah. Okay, I recently discovered something that will really help with this question, and sincerely, I've never used this method before. So it's like as you can see, I talked about creating a hash or a map of every item in each of the arrays, right? And a simple way to do this, I mean, for us to do this in the normal way, is to write a function, right? And that function will simply iterate through every item in the array and then add them to a dictionary, and every time the array is seen in the dictionary, right, the count or the value of that item in the dictionary gets increased. But there is a very simple method in Python. It's a class, I mean, it's a module that we need to import and use, right? Obviously, apparently, I mean, it's a common thing people have been doing, and I don't have any doubt about it not being legit. So here's what I'll need to do. Instead of doing that, right, I mean, we can still create our class, right? I mean, we can still create a function that helps us build this dictionary, but there is no point wasting time. I mean, it's not a waste of time per se, but it's also good to know there are tools out there that can help us do these things. So it's called a counter, right? So I'll say from the collections module, we'll need to import the counter. So yeah, it's called counter like this. Now this counter, let me just show you in the playground. I use my playground for examples. So I'll say I'll just let me add an items to this. I'll say 1 2 3 4 5, right? Or let's say we have 2 here, we have 2, and then we have 1 here. So we want to create a dictionary out of each of the items in this nums array here. So we can use the collections module to do that. So I'll import the collections here and just say I'll call this nums count. I'll call this nums count and say it's equal to the counter class here, and then just pass it the nums, the iterable, right? And this will simply count every item and create a nice dictionary for us. I did not know about this before, so yeah, it's good to know now. So nums count here like this, and then I'll run this. Now you can see it's nicely created a dictionary for us, counting each of the item, the occurrence of every item in the array, right? We can see that 2 occurred 3 times, 2 is 3 here, and then 1 is 2, 3 is 1, which is awesome. So that saves us a lot of time, and we'll simply do that here. So we'll say I'll say nums1 count, right? Nums1 count is simply going to be equal to the counter of nums1. Now if this feels like nice job being consistent. Oh, thank you very much. Somebody said something in the chat. That's really nice. I appreciate that. Okay, so if this feels like you know, I don't know, I actually always preach on, doing everything by ourselves, but I can still do it, right? I can still create a function that returns the count of every item for us, but I don't want to waste any time. And also, by not wasting time, how much time is it going to take me to create this? It's not going to take a lot of time. But when I don't know, let me just use it and stop talking. Oh, sorry, I was saying nums2 count, right? Nums2 counts, and I'll just say it's going to be the counter of nums. Oh, I put nums2 here instead of nums1. Nums1, and this will be nums2. Nums2 like this, right? Now we have both our sets now, right? So we can see for num, now this num here, right, is going to be, let's say for nums1, if nums1 was this array, right, it will be the entire array as a key value pair, right? So but I mean, if I did for num in count, num1 count, right? Oh, why is it taking nums2? Nums1 count, right? Then it will take every value, right? Every key, right? Every key. Dictionaries have key and then values. Let me just show you this. Let me write this again. Now you can see this is a key and then this is the value. Now what we are interested in the most, right, is the value first and then the key. Now the key will give us an indication of the occurrence of each item. So now, but first of all, we start with the key first of all. So now we can say if the num, right, if num in, right, in nums2 count, right, if the num is in nums2 count, right, then we need to get the minimum or between the two. So I'll say minimum count will simply be equal to the minimum between those two. Now to get the value, we'll simply use the key, right, the key to get the value from nums2. So this is going to be nums1 count, right, nums1 count here, and then we use a square bracket to get the value. So say num, and then we'll pass it nums2 count like this, and then we'll pass it num like this. Now this will give us the minimum between these two. Now mind you, this will only return the value and the occurrence of each of the item in the array. How many times the item appeared, how many times the item was counted, right? Now we want to add you know, so I did not create my result array, so I'll call this results and set it to an empty array. Now the reason why I need result is to add you know, the occurrence of that item in the array, because at the end of the day we want to return a result or an array of integers. So how do we do that? Well, we'll simply say result. Now, like I said before, we will not do result dot append, right? We want to do result dot extend, right? So result dot extend. Now the reason why we need to extend, let me just show you, because at the end of the day, right, we want to add the amount of time that the minimum amount of time that particular number occurred in both array. In other words, the intersection and how many times it happened, right? So for us to do that, right, we will need the minimum count multiplied by that item, right? So we need to multiply that item so that we can have it as much in the result array. So if we do dot append, right, let me show you what dot append would do. So I would just take this out, right? Okay, you know what, yeah, let me just take this out. I'll start with an empty array, just focus on this. So let's imagine nums2. Okay, this is an example of, so this is no longer nums. I'll just remove all of this here and show you what this does. So here is you know, the nums array, right? Now let me do dot append. Now dot append will add an array of arrays in this array, in the nums array. So let me print this. Now you can see we have 3 and 3 as an array. Obviously it was doubled, right? But for us to extract this 3 and 3 and add it to this array, we don't use append, right? We instead use extend, meaning extend this array, extend every value in the array into this new array, right? Because this is going to be an array. We can't do 3, we can't just do 3 times 3 like this. This will become 6. We want 3 twice, right? And for us to do that, the only way we can do this that I know of is to put it in an array like this and then multiply it by how many times we want to add it to the nums array. So by using extend, right, we'll simply extract that value and then we'll have the array like this. So, and we just say extend, and then we do this. We just say nums2, sorry, extend an array of the num times the minimum count, right? So this will build up our array, right? And then we simply need to return the result array. So return the results. So here's what we need to do at last, and we are done with this question. So let's take this to LEETCODE and run it in LEETCODE and see what will happen. So I'll copy everything. Now we don't need this typing, and I don't think we need to even import anything on LEETCODE. You can simply run everything in LEETCODE, and LEETCODE will automatically import the classes. I am sure of that. I don't really know. Let's try it and see. If they don't, then we'll need to import the classes ourselves. So okay, so let's run this and see. Okay, it worked. So the classes were imported for us, so we don't need to import. I'm a bit skeptical about this. You can see 46 milliseconds. That's not really good, but I'm not sure. Are there any constraints? Okay, I read this question before and I forgot to read this. What if the given array is already sorted? How would you optimize your algorithm, right? If the given array was already sorted, I mean, there were hoping, or suggesting we would use binary search, but I don't really think binary search is necessary at this point, because we'll need to sort an array to perform binary search, right? And then what if does not mean the array is going to be sorted all the time, right? So it's just a guess. So how would you optimize your algorithm is to just use a set, right, or a dictionary to count every item. And what if the size is small compared, what if size of num1 is small compared to size of num2, which algorithm is better? What if elements of nums2 are stored on a disk and the memory is limited, such that you cannot load all elements into the memory at once? Well, I don't know too much about that, but let's see what we have here. So let's submit this. I mean, we've passed 2 test cases already, so which is pretty good. Hopefully this works. Yeah, it worked well. I mean, like I said, I was a bit skeptical about the runtime. I know it probably wouldn't make it past, or make it up to 50%. Surprisingly, I was right. But in terms of memory, we didn't create much memory in space, and I'm sure it's because of the count method that we used here. This was, I mean, this worked, which is really good. I mean, it's a first step to improving the solution, so we can look a bit more into that later on. But so far so good, right? A good attempt is better than not just trying at all. So congratulations. So I will submit this first of all, so that you have access to this code. So the GitHub repo for every questions I've been solving so far is in the description, so you can have access to it in the description below. And don't forget to keep learning every day, right? Just tune in whenever I'm streaming, or you can look at the titles and yourself. I mean, you too, you can, solve some questions too every day, right? A question a day keeps, what would I say? I don't know what to quote. So, let's say git add, git commit -m, and we want to commit LEETCODE. So this an array question, right? Although I saw it in the binary search problem list, I wouldn't call this binary search, because I did not use binary search to solve this question. So so this is going to be array, and then this LEETCODE dash 350, and then yeah, so this is going to be intersection of arrays 2, like this. Okay, so that has been committed, so we can then go ahead and solve one last question on the list. My last question on the list is very similar to this question, which is why I actually chose it, so that we can learn pattern recognition to solving LEETCODE problems. So the question was simply, the question was simply here. It is find common characters, right? Find common characters, intersection of multiple arrays. We can also find that as well. Minimum common value. We can also do that as well. These are all, they are all similar, right? They are all similar questions. You can see intersection of multiple arrays. So we did intersection of 2 arrays, right? So I mean, in this case, I think a binary search might work, right? A binary search might work, but I mean, I did not even read the question, but the previous method I used will work, right? It will work, because we are simply looking for, you know, you know what? Let's see. Let's see this question first of all, because I mean, all of these questions are all the same. They are all the same. They are all similar, and I'll show you how similar they are. So here is it's code 1002, and it says find common characters. Right, given a string, given a string array words, return an array of all characters that show up in all string within the words, including duplicates. Now you can see the similarities, are beginning to take shape. You may return the answer in any order. Now you can see we have a word, an array of words, right? And then we want to return an array of every character in this array. Now, why is this question similar to this other question here? Well, we are given two arrays. In this case, we are given two arrays. The arrays are also iterables, right? And then we simply took, how many times, a particular word, or a particular number appeared in the other array. A particular number of the first array appeared in the other array. In this question, the difference here is just that we are dealing with characters. We are dealing with alphabet letters, right? So we simply want to check how many times a given letter in a particular word, right, in a particular word appeared in every other word in the same array, right? Simple. So all we need to do is to compare, we need to create a counter again, right? We'll count we'll count each letter in each word, right? We'll count how many times each letter occurred, or how many times they appear in the word, and then we'll also compare it with every other word in the array and see how many times those letters appeared, the minimum amount of time they appeared in each word, and then we'll just multiply and add to this array. So if that doesn't sound clear, so let me show you an example, right? So I'll copy this and bring it here. So I'll then paste this here. Okay, let me paste it here. Oh, okay. Control Shift V. So Control Shift and then V. Okay, so this will paste it properly for me. I always forget to do that. I don't know why. Control Shift V. Okay. So should I use? Now like I said, we need to create counters for every value, right? Now, why do we need to create counter for every word, right? We want to know, first of all, if a particular, so we need to choose one word as our like we did in the other example. We used one array, which is nums1, and then we use every character in nums1's count, right, to compare to nums2's count. Let me show you here. So you can see we created nums1 count and nums2 count, but we chose to use every character in nums1 count to compare, to find if that character is in nums2 count, right? If that character is in nums2 count, then we add it to the result array, or we find the minimum first and then we add it to the result array. So we'll do the same thing here, right? So we'll say I'll call this now there's a difference to this question. We're not only comparing characters between two words, right? It's not going to be two words. It's going to be more than two. I mean, we don't know the size of the array, right? Sorry. We don't know the size of this array. So it's going to be either between two words or more than two, which is three. So um here's where things become tricky, because I mean, if we took, okay, let's say we took word one, let's call it I'll say uh or let's say I'll call it first count, right? I'll call this first count. So this is going to be a count of every word. So B is here. How many times did B appear? So far we have 1, E is 1, and then L is 2, L is 2, A is 1, like this. Okay, now we'll need to compare this count to every other word in the array. So here's where things become tricky, but then the application of this solution is still going to be the same. So we'll say for every character in this, we want to compare it to the count of every character in subsequent word in the input in the words array. So we'll do something like this. So we'll loop through this array, but while we are looping through this array, we'll need to create a count for every one of this, right? I mean, we'll loop through this word array, right, starting from the second word, right? So we'll say for each word, right, for word in words. Now in words, but we want to start from the second word, right? So we can say length of from 1 to length of word. So we can use a range function. So if we iterate, I'll just put a dash here so we can know that we are creating we are looping through the words array, right? So now while we are doing this, we'll say we'll create the words. Now, okay, we'll call this current count, and then here is where things become similar to this question. Now, current count will first of all take this we'll take a count of the second value in the array, right? So we'll call that current count, current count, and we'll use the counter function again, right? So using the counter function, we can create a count like this. So we have label, right? So L in label appeared twice, right? We have one L here and another L here, right? So, and then we have A, B, E. So A, B, and then E, right? A, B, E, like this. So A is 1, B is 1, and E is also 1, like that. So we use our original method, but now this will become very interesting. If we went straight ahead and found the minimum like this, then we are simply ignoring the remaining we are simply ignoring the remaining items here, because at this point we would have calculated the minimum between these two, right? Between these two, the minimum occurrence of every character between these two, only if we went ahead and did it this way. So instead of calculating the minimum count, right, we'll simply ignore the minimum count for now. So we'll say, right, for every character in the first count, right, if that character is in the current count, right, we'll update our first count with that character, right? We'll keep track of it. So, but if that character is not in our first count, then we will remove it from the first count. Now let me explain why that's we will have to do it that way, because at the end of the day, right, at the end of the day, if the character is in the minimum count, right? If the character is in if the character is sorry, if the character is in the current count, we'll add it to this you know, we'll add it to the first count here. Now we are not adding that character straight away. We are adding the minimum count of that particular character. So we'll still have to perform this, but going straight away to remove the to find the result will not happen at this point, right? We'll need to update we'll need to update our first count, or I don't know what's a better variable name to give this. I'll call this main count or whatever. So we'll need to update this main count with every other value here, with the minimum duplicate of every other value. So since L is 2 here, right, and then L appeared twice also in this, L is also 2 times since L is also here, right, and then we also have 2 L's in every other value, in any other, oh god, since L is here, sorry, my throat became dry briefly. Since we have 2 L's here, or let me just say, since we have L in this stationary and we also have L here, right, this is the current count we have here, we'll find the minimum between these two, right, and then update the value of that minimum with our first count, or let's call this the main count, right? We'll update the value in that dictionary. So if the minimum here was 1, right, if this was 1, then this will no longer become 2, right? I mean, will no longer be 2, sorry. This will no longer be 2. We'll update this to become 1, right? We'll remove the 2 here. But since 2 and 2 are here, that's fine. We'll keep the 2 there, right? Now, the next value we want to look at is, okay, so I jumped to L, which is not really what I should be doing, but I should have started with B. But anyways, if we found a B here, right, B is also here. So how many times did B appear in both words? Well, B appeared only once, so we keep B the way it is, right? The minimum between 1 and 1 is still 1, so we keep B as 1. And I think every other value here is also here, so this will just pass the check for I mean, label and Bella are made of the same words, I mean the same letters, so it's cool. Now where things become interesting is when we get to roller, right? When we get to roller, now we need to do something different. Now since we are using this as our main count, we need to update every other value that is also not we need to update every other letter that is also not in the other word, right? So here's what I mean. If let me erase this, is that if our current count, right, is now the word roller, right, which is this last word here, let's create the count for the map for roller. So this is going to be R is going to be 1, O is going to be 1, L is going to be equal to 2, E is 1, and sorry, R is going to be 2 because we have another R here. So now we'll compare the values at this point. Now R is not in this what do you call it? R is not in this dictionary at this point, right? So we just add R 0 times to this dictionary here. In other words, we don't even need to add it, right? It's going to have a value of 0, so we don't really need to update our dictionary with this. But if a value is in this dictionary that is not in the other one, we'll also remove it, right? So like for instance, we have an O here, we don't have O here, so we 0 time, right? or we have a B here and the B is not here, so we'll set this back to 0. We remove everything that is not in the other side. So you know, we don't have O here as well. There's no need for us to add it there. E is here, so we only have one E. We don't have so L is 2 here, L is also 2 here, so which is good. A is not here, right? So we remove A from the dictionary, which is going to be equal to 0, right? And then E here is 1 here, is also 1 there. L is 2, we don't have 0. So we'll end up with a dictionary like this. So we'll have E, right? E is 1. So we have 1 E. We have 2 L and 2 L, right? We removed all of this. So this will not go into that place. R will not go there. So we'll have L and E. So 2 and 1, yeah. So we'll end up with the dictionary like this. So our main count will become something like this. Now, this is what we will need to add to our array, right? So our output array or our result array, and then we will multiply the value of every character by, you know, the corresponding value, or every letter by its corresponding value, and add that to our result array. So enough of the talk, let me just code this out for you to see what it is like. So I'll just go ahead, and so this is going to be what's find common character 1002. So find common character, so this is going to be arrays LEETCODE 1002. So LEET 1002 find dash common dash array. Find common array. So find common what? Not common array. Oh my god, I hope I don't remove this. Find common characters. So I'll just say find common characters like this. Yeah. So let's copy, you know, this like this. I usually do that, and I'll close this here. So I'll need to import this from typing import. So we'll say from collections import counter. Okay, so we imported counter from collections array. Now here's what we need to do. We'll first of all take our counter. I'll call this I want to call it, I'm so tempted to call it main counter, but I will need a better name for it. What's a better name for this? I'll call this okay, let's call this tracking counter. Now tracking counter will start with the first word, right? So we'll say counter of the first words at 0. So we'll take the first word. So we'll find the first counter like that. And then we'll say so for the remaining words, right? For I in range so we are starting from 1 all the way to the last. So len of words, right? Len of words, len of words. We want to take each word and create a counter for it. So I'll call this current. So this is going to be current counter, right? Current counter is going to be words at I. So this will start from 1 and then we'll compare. So we'll say for character in tracking counter, right? For letter or character in tracking counter, Now if the character is in the current counter, right? The current counter, then we'll update that character in the in the tracking counter. So the tracking counter, the character again, right, should be equal to the minimum time the character appeared in both counters, right? So we'll say current counter, current counter of the character, and tracking counter of the character here, right? So we'll find the minimum between these two, right? And what's going on here? Minimum, hold on, for the character in tracking counter. Yeah, I mean, what's this? Instead got string as supported index. Current, hold on, for each character in tracking counter, if the character is in the current counter, right, then the character in the current counter, I don't know what this error is. So expected string generate instead got what? Got integer instead. Yeah, I mean, I'm trying to get the, you know what, that is not an issue, so let's continue for now. If it comes up, then we'll, I mean, so if the character is not in the current counter, right, else then we'll update our tracking counter of that character, tracking counter of that particular character to 0, right? We'll remove it because, yeah, sorry, we set it to 0. Okay. Oh, right. So we'll set it back to 0. All right. So at this point we would have built our tracking counter, and I would like to see it, right? I would like to see what it looks like. So I'll print the tracking counter here, tracking counter, and let's just implement a simple solution here. I'll say solution is going to be equal to the solution class. Let's create an instance of that class and print solution like this, solution dot common characters. So we'll copy a list of characters here. So I'll take the words here and let's see. So print, I'll put words here and pass it the words like this. Now we are not done with the question. I'm just trying to do something quickly. Okay, so I knew there was going to be an error. So current counter, I mean, what's happening here? What's the error saying? The error says, so indices must not be string. How is that? I mean, I want to get the value of the current index of the current character, right? Must be integers, not string. How? I mean, if I'm creating the current counter here with hold on, what's going on here? I want a number, right, between these two. words at I, right? Words at I. If character in tracking counter. Oh, I see what's happening. Christ, I'm not creating a counter here. Oh, my bad. Okay, so sorry about that. Now you can see we have managed to remove, and we have our double L and then E, which is 1 here. So we'll run a second iteration over this tracking counter, right? And then take the key value pairs and then just multiply them and add them to the result array, right? So here's what we need to do. We'll say for how do we get key value pairs from a dictionary? I absolutely do not know. So let's see how to get key values from dictionary in Python. So keys values from dictionary in Python. My dict the keys. No, I mean in an iteration. I like coming here because things are like straightforward. Yes, so for keys values in dictionary.items. So let's do that. So for keys, right, keys and then values. So instead of calling them keys, we'll call them characters, right? And then I'll call it count. The values are the how many times in tracking counter dot items, right? Good. Yes. So we can do that, and then we can say so we need a result, right? So we'll say I'll create my results here. Results is going to be an empty array, and then I'll say results dot extend an array of the characters times count like this. Sorry, characters times count, and then at the end of the day we don't need this, so we'll just return the result. So return result like this. We return the results. So let's see if we have that. Yes, it works. So let's test this out in LEETCODE and see if we've passed some test cases here. Now there are not much edge cases to this question, honestly. Maybe I didn't read them, but you can see there's always going to be a word, right? Word I the length, so each word is going to have at least one character, right? So word the length is superior to 1, blah blah blah. Anyway, you know what, I might be making a mistake here. I don't know if this solution works, then I'll be very surprised, but because of the way I'm iterating through the array here, how sure am I there's going to always be two two words, right? I mean, there's going to be more than one word, because the constraint here says the array is the words are going to be either more or equal to 1. So between 1 and every other value above 1. So let's see, let's run this first. Okay, so we pass both test cases here. Let's run this. Hopefully this fails. Okay, it worked. Oh, I was hoping it failed, and I'll have to struggle a bit to find out why. But I mean, that's a big relief. So I'll just, commit this as well. I'll commit this again. So this is going to be git add, git add, git commit dash m. We need to, so this is arrays, right? And this is LEETCODE 1002, right? This code 1002. Find common characters. Find dash common dash characters. Okay. And then say git push origin main. Okay. I mean, you can have access to both solutions in the description. The GitHub repo is linked in the description below. All right. Thanks for watching, and thank you to everybody that was in the stream. We'll continue tomorrow with a new question or a new topic. I've not been feeling good this week, so I might seem maybe slow, but hey, it's good. It's good to be here and try out these things every time. And see you tomorrow. Bye. Okay, so let me quickly take a picture.